Okay, welcome to our first lesson on sequences and recursion. So this is the first little subtopic within the topic of growth and decay in sequences. So it's a nice one to start off the year. First of all, what is a sequence? So if we look down here, we can see that I've got a bunch of numbers listed from left to right, 12, 22, 5, 6. They've all got commas between them, and there's an ellipsis at the end. So if you've forgotten what an ellipsis is, it's just those three dots just there. And we do that because we don't want to keep writing all the numbers. It might go on forever, indefinitely, or there might just be too many to write, and we are mathematicians and are lazy, so we don't want to write them all, and we write an ellipse. So a sequence is literally just a list of numbers written down in succession. They have commas in between them. One thing to note about a sequence, each individual number, so the 12 or the 22 or the 5, is called a term. So the terms all sit in succession and make a sequence. Let's have a think. What could this sequence represent? Well, it could really represent anything. It might be the ages of people on a bus. It could be anything that fits contextually those numbers. Is there any pattern or rule to the numbers? Well, let's have a look. 12, 22, 5, 6. I certainly can't see a pattern there. They look fairly random to me. So no, I don't think there's a pattern there. And we used the word random before, and that's exactly the right word that we would use to describe this sequence. It's called a random sequence. So something that doesn't have a pattern is called a random sequence. So something there's no real rule to work out what the next number is. So this one's a random sequence up here. Sometimes sequences do have a pattern though. So 1, 3, 5, 7, 9, you've all probably picked up that there's a pattern happening there. So everyone is being, each number is being added by 2 to get the next number. So we call this a rule-based sequence. And the reason it's called a rule-based sequence is that we could apply a rule to work out from one number what the next number is. So the rule for this one would be add 2. So from one number you add 2 to get the next number. So that's a rule-based sequence. So we've got random sequences and we've got rule-based sequences. There are two ones we've learned so far. We just went through what the rule is there. So that would be 1 to 3, we add 2. 3 to 5, add 2. 5 to 7, add 2. 7 to 9, add 2. Be really careful. Sometimes it's not always going to be an addition. It might be a subtraction or adding a negative number. So sometimes you could be multiplying as well. So you might go 1 to 3, the rules add 2, but then the next number might be 9, and you realize, wait a second, 3 plus 2 doesn't equal 9, there's something else there. So 1 times 3 would get you to 3, and then 3 times 3 would get you to 9. So the rule in that case might be times 3. So be really careful. Don't just always use the first 2 numbers to work out what the rule is. Check and make sure it works repeated times. The key points about sequences. A sequence is a list of numbers in succession. Each number is called a term. Don't forget to use the correct terminology. Ellipses are used to show that the sequence keeps going. Types of sequences, we can have random ones with no pattern, or we can have rule-based ones where there's a pattern and there's a rule to predict what the next term is. So that's all the basic stuff about sequences. I think we can probably agree that that's fairly easy. The next thing we're going to talk about is recursion. And recursion's a special technique we use to generate a sequence. But the thing with recursion is you have to have a starting point. So you have a given starting point. So your starting point is 2 or 7 or whatever the starting point might be. So the first term is your starting point. We start there and then we build up the sequence one term at a time. So recursion works one at a time by applying a specific rule. So that's the concept or the technique of recursion. You start at the start, you apply the rule to get each number term by term. So from above, that example we had was 1, 3, 5, 7, 9. Our starting value is 1. And then our rule is add 2. So a starting value of 1, we add 2 to get 3. We add 2 to get 5. We add 2 to get 7. So you can see how it happens term by term. So let's have a go at using recursion. So write down the first 5 terms of the sequence with a starting value of 3 and the rule multiply by 4. I have given you the solution, but you could see how that would work. So let's do it with a different set of numbers. Actually, let's go a starting value, and you guys can pause the video here if you'd like and give it a go. So have a go with a starting value of 7 and a rule of multiply 2. So have a go at that one. When you think you've got it, come back and check your solution. So starting value of 7 would be my first term. 7 times 2 is 14 to get my next term. 14 times 2 is 28 to get my next term. So we want the first 5 terms. We've got 3. 28, oh, whoopsies. 28 multiplied by 2 is 56. And one more, 56 multiplied by 2 is 112. So they're the first 5 terms of the sequence. Remember, sequences are a succession of numbers written with commas between them, so we haven't really communicated our solution properly. So my solution should be 7, 14, 28, 56, and 112. And I'm going to indicate that this keeps going. We're just writing the first 5 terms. So that's how you would do something like that. Again, I think we can agree that that one's fairly simple. You can also do it with a calculator. Yay for laziness. So our scientific calculators, you don't need a graphics calculator for this. Scientific calculators do it really, really easily. So the way we use our scientific calculator is we type the first term. So in the example that we did above, starting at 7, we would type the first term of 7, hit equals, and then you'll see that 7 comes up in the answer spot. And that stores the value. So your calculator has a memory. So it's stored in the memory. Then you type your rule. So once you've got 7 as your answer, the next thing you do is write multiply 2, and your calculator will show answer times 2, hit equals, and it will give you the answer 14 in the answer spot. And then you copy that down in your book. So you've got 7, oh cool, I got 14 for my next one. Then in your calculator you hit times 2 again, and it would come up with answer times 2. And then equals give you the answer, and so on until you have as many terms as you need or as the question asks you to have. So pretty simple. I'm sure you've all done that before, just in other topics in maths. You've used a calculator to get values, and sometimes successively. Okay, so you guys have a go. Use a starting value of 6 and a rule of multiply 3. Generate the first 7 terms of the sequence recursively, so one by one, using a calculator. So at this point, pause your video, go off, 7 times 3 times 3, 6 times 3 times 3 times 3, until you have the first 7 terms of the sequence. Okay, so I hope you've done that. Once you've finished, that's kind of all the content we're going to deliver today. So it's a nice simple lesson to start off. You've got exercise 4A. I'd like you to complete all of it. However, if you are finding this very simple and there are a lot of repeated questions, you have the level of maturity to look at those questions and say, you know what, I think I might just do every second one. I still want you to do every question, but you might pick and choose what parts of the question that you do. So exercise 4A, for the remainder of the time that you have, go on with those questions. Before you move on, make sure you can answer what is each number in a sequence called. If you can't answer that question, go back through the notes and have a look. And what is the difference between a sequence and a rule-based sequence?